Welcome to 8.2, the law of sines. Some of our objectives are to solve side angle angle or angle side angle triangles, take a look at solving side side angle triangles, and solve applied problems. Okay, so if we want to solve a triangle, that means find all the missing angles and sides. This one gives us an angle, a side, an angle, an angle, and a side. So, looking back up here, we have two angles and one side, so we're going to be applying right away side, angle, angle. Now, why is this important? Because law of sines, we need one of these to happen. Side angle, 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 side angle. So this allows us to use our law of sines. We are looking for, so what are we missing? We're missing B. We're missing little b, so our side B and our side C. Angle B, side B, and side C. Let's start with finding our missing angle. We know that it has to add up to 180 degrees, so I'm going to subtract off 14 degrees and 23 degrees, and that leaves us with 143 degrees. So B is 143 degrees. And now that I have all of my angles, it's really open for me to choose how to solve for my sides. First, let's find side B. So what I did was sine of A over A equals sine of B over B. This leaves us with sine 14 over 3 equals sine 143 over B. Using our cross multiplication, we get B equals 3 sine 143 over sine 14, which is approximately 7.46. So our side B is about 7.46. And if we find side C, we can do sine of A over A equals sine of C over C. Sine 14 over 3 equals sine 23 over that missing C. Using cross multiplication again, C equals 3 sine 23 over sine 14. Through our calculator, that's approximately 4.85. So side C is approximately 4.85. And we found all of our missing pieces. So that triangle has been solved. All right, let's solve another triangle. We are given angle, angle, side. So let's do it again. We know that it has to equal 180. So if I take off 32 degrees and 33 degrees, I'll be left with 115 degrees. So C is 115 degrees. We're missing side A and side B. And for side A, we can do sine A over A equals sine C over C. This gives us sine 32 over A, that's missing. Sine 115 over 4. Using cross multiplication, A is 4 sine of 32 over sine of 115, which is approximately 2.34. So A is 2.34. There we go. For B, we can do sine C over C, sine B over B. There we go. So we'll have sine of 115 over 4 equals sine of 33 over our missing B. Through cross multiplication, we get B equals 4 sine 33 over sine of 115, which is approximately 2.4. So we have 2.4. And we've solved our next triangle. Okay, two sides and an angle are given. Determine whether the information results in one triangle, two triangles, or no triangles at all, and solve any triangles that result. So this one sounds like it's a little tricky, and in some cases it might be, but once you get the hang of it, it's not so bad. All right, let's look at this first one. B equals 10, C equals 9, and angle B is 36 degrees. So first, why don't we find angle C? I'm going to start with sine B over B equals sine C over C, because we have the side and angle for B, and we have the side for C. So this will give us sine 36 over 10 sine C. We don't know the angle, but we know the side is 9. So using our cross multiplication, sine of C is 9 sine 36 over 10, which is approximately 0.53. Now that's the sine of C. So if we take sine inverse, C is sine inverse of 0.53, which is approximately 32 degrees. And the way to check if it makes 1, 2, or no triangles is by using this angle. So 32 degrees, that could be one of them, right? So let's say that C1 is 32 degrees. And if we wanted to check that there was another angle, then we would take our 180 minus that 32 that we found. And what we're doing is we're trying to figure out, okay, is there more than one angle that this could work? So in your book, it shows a really good example of two triangles where this angle would give us length of x, but so would this angle. It would also give us so we have this angle, and then we also have this angle that would both satisfy the same one. Obviously my drawing is very bad and not to scale, but it's the idea that there might be more than one angle that would satisfy this triangle. So if we did 180 minus this angle, that would give us 148 degrees. So this is a possible second angle. But let's talk about this logically. All of our angles can only add up to 180. So if we have 148 plus 36, we're already over. And we've only found 2 angles. So that is greater than 180, which tells us there is only one triangle. Which is great because that's what we're used to. We're used to just finding one triangle. So let's continue. We found C. So what we can do is 180 minus 36 minus 32. That will leave us with 112. So A is 112. And the last thing we're looking for is side A. To find side A, we can do sine B over B equals sine A over A, which would give us sine of 36 over 10 equals sine of 112 over that missing A. Cross multiply. A is 10 sine 112 over sine 36, which is approximately 15.77. And we have done it. We've solved it. We have even determined that there's only one triangle. Okay, let's do another one. Here we're given side of 8, side of 9, and angle of 18 degrees. So first, let's find another angle. Let's do sine B over B is sine C over C. Again, I'm choosing these because I'm given side B and angle B and side C. So all we're missing in this case is angle C. We have sine 18 over 8 equals sine of missing angle C over 9. Through cross multiplication, sine C equals 9 sine 18 over 8, which is approximately 0.348. Now that's the sine of C, so if we want C, we need to take sine inverse of 0.348, which is approximately 20.34. Now we're going to do the same thing. 20.34 is a possible C1. Is there another angle that would satisfy this triangle? So we will check 180 minus 20.34. And that gives us 159.66. Now, if that is angle C, and we have angle B of 18, that's still less than 180. So this 159.66 is our second value. So this one has 2. two triangles that we have to solve. So what are we even looking at here? Let's get a visual. What's happening is we were given that C is 9. We were given that B is 8. And then we found out that there are two triangles. So B is still 8, but it works on both of these. So as we move along, it'll be at length of 8 and hit the bottom triangle, and if we move it all the way across, it'll still be a length of 8 and it'll hit the triangle again. Kind of like a swinging door. Now our angle B is actually going to be a B1 value, 18 degrees here. And we found two C values. So one of our C values, C1, was 20.34 degrees. And our other C value, C2, is 159.66 degrees. So now we can find our A1. We'll do A1 up here by taking 180 and subtracting the 18 and the 159.66 out of the smaller triangle, and that will give us 2.34. So over here we have 2.34, and then on this side we will have our A2 and we'll have our B2 on this side. So I guess I need to switch the C's. So this is triangle 1 and this is triangle 2. And then we've got we can find, let's see, we are missing, we have C, we have B, we have B, we're missing our little A's. And I think that's, oh, we are missing B2 and A2. Okay, so for B2, for this angle here, I know that these two angles have to create 180 degrees because that's a flat angle. So what I'm going to do is take 180 and subtract 159.66, which is going to give me 20.34. So this angle, B2, is 20.34. And then to find this angle, A2, we're going to subtract 180. We're going to subtract 20.34 and 20.34 because that triangle has to equal 180. So 180 minus 20.34 and another 20.34, which gives us 139.32. So this angle is 139.32. I think we have all of our angles. We just need our sides, little a1 and little a2. So let's start with sine. I suppose we can do sine of B2 with sine of B, which equals sine of A2 over sine of little a, or not sine. I'm getting really excited about all the signs. Okay, A2. There we go. Sine of B2, the angle B2 over side B equals sine of angle A2 over A2. All right, we've got so many triangles on here that it's getting a little wild. Okay, so B2 is the 20.34 over B, which is 8. Sine of A2 is sine of 139.32 over that little a. And we can do our cross multiplication. A2 will have 8 sine of 139.32 over sine of 20.34. In our calculator, that should give us about 15.00. So this one is 15. And we have one last one to solve. So we can do sine of B1 over B and sine of A1 over A. So this gives us sine of 18 over 8 equals sine of 2.34 over our missing value A, which leads us to 8 sine of 2.34 over sine of 18. And in a calculator, that's approximately 1.06. So this one is 1.06. And there we go. We found all of the values for both triangles. We found 6 angles and 6 sides. Well, 5 sides because they share one. Okay, how about this one? B equals 4, C equals 6, and B angle is 93 degrees. So let's start with sine B over B equals sine of C over C, like we have before. This is going to be sine of 93 over 4 equals sine of that missing angle C over 6. So sine of C is 6 sine 93 over 4, which is approximately 1.498. Now we're noticing that this sine is greater than 1, and there's no angle C that will give a sine greater than 1. So this one has no triangles. What's happening is one of the sides isn't reaching the rest. So no matter where you put it, it will never reach. So it's making an incomplete triangle. What a sad day. Okay, now time for our application problem. 2 sensors are spaced 685 feet apart. Okay, so let's start with sensor 1 and sensor 2, and we are 685 feet apart along the approach to a small airport. When an aircraft is nearing the airport, the angle of elevation for the first sensor is 20 degrees, and the angle from the second sensor is 9 degrees. So we have a plane coming in, and its angle from the sensors are 20 degrees and 9 degrees. Determine how high the aircraft is. So we want to know the height of the plane. So, what can we do here? Well, we know that this angle, actually, I put them in the wrong places. So this angle is bigger than this one. Okay, there we go. So what I'm trying to say is, since this is making 180 degrees, we know that this angle is going to be 160 because we already have 20 of it. Then we can use our knowledge of this triangle here, because we have 9 degrees and 160 degrees. We know that total it has 180 degrees. So if we take out that 9 and that 160, we'll be left with 11. So this is 11 degrees. So let's use some law of sines. If we take sine 11 over 685 and set that equal to sine 9 over, we don't know, we'll label this A. Then we'll get the distance from the plane to the sensor, but this is a middle step because what we really want is this missing height over here. So what we're doing is we're doing this step to fill in this second triangle a little bit, so that way we can find that missing value. So let's find this A. Sine 11 over 685 equals sine of 9 over A. Using our cross multiplication, A is going to be 685 sine of 9 over sine of 11. Throwing that through your calculator, you should get about 561 feet, a little over half. So this A, this distance is 561.596. And we're closer to getting that H. So now we can find H by taking the sine of 20, because we know we're looking for the opposite and the hypotenuse, which is sine. Sine is opposite over hypotenuse. So sine of 20 is the opposite at H over the hypotenuse, which is 561.596. So if I multiply the 561 over my height is 561.596 sine 20, which is approximately 192.08 feet. So we would want to say the aircraft is approximately 192.08 feet high. Okay, and there we go. We got to do law of sines and our trig function.